Hello everyone, this is Professor Chan for Math 1245 speaking. We're going to continue on with section 4.4. Let's just do a practice from the last video. So we are solving a logarithmic equation. Okay, so as you can remember, see I have natural log, which is base e, and I want to combine them. So notice I have subtraction, so I realize I have to divide, so it looks like this, right? Natural log of x plus 1 divided by x is equal to 2. Now when I swap it this time, I have to realize that I have a base e on the bottom. So I'm going to swap these two. And this is going to be equal to e squared x plus 1 over x. Okay? So let's talk about how I solve for it. So remember the following here. What I'm going to do is I'm going to multiply both sides by x. This cancels. So what I'm going to do is, remember, I want all the x's on one side, so I'm going to subtract. So this becomes ex squared minus x is equal to 1. Or sorry, e squared times x, my apologies. So I can pull an x out. So this is e squared minus 1 is equal to 1. And then divide. Remember, e squared is just a number. Okay? So essentially I have an x times a number. So I'm going to divide both sides by e squared minus 1. Okay? Now let's talk about this too. I forgot to talk about this in the last video. But idea is if they ask you for an exact solution, this will be your exact. Okay? But they say approximate, that's when you use your graphing calculator. So I can just throw this in my calculator here and do 1 divided by e squared. So second division. And that gives me approximately 0.157. So you can also write it like this. Or you can write it like x is approximately 0.157. So this is an approximate solution. Okay. Yeah, sorry, this should be e squared. Okay, so we're going to move on. Let's just talk about a couple other things here as well. So we're going to move on to the next type of solving, okay? So the next type of solving is what happens if I have an exponential equation and I can do this. Okay, so before we continue on, so remember we did solving through what's called change of bases, and we can also do solve using properties of logs. And then now you can also solve doing the logs of both sides, okay? So generally we take the log of both sides, especially if I have an x in the exponent form. Okay, so let's do a more simpler one. Let's look at example like number 2. Okay, so number 2, the situation for number 2 is this. I notice that I have 2 to the x, and that my unknown, which is my x, is in the exponential form, which is going to be hard to solve. So I need to think about how to kind of get rid of that. So what I can do is, remember, I can take the log of both sides. Okay? Why would I take the log of both sides? Remember, right, one of our 3 properties is if I have an exponent, what happens is I can take that and I can move it across like this. Okay? So, and I have x times log of 2, log of 10. Okay, now, here's a thing to be mindful about. I know the log of 2 is a little confusing, but if you put in your calculator, you should realize log of 2 or log of any number is just a number, okay? So really, in actuality, right, you essentially just have x times 0.30102999957, okay? So it's really x times a number, okay? Another thing I want to talk about is this right here, okay? So when we write, when you have x next to a log of a number, always put the x in front, okay? Because if I write it like this, if I do log of 2 times x, that's really confusing because you would think of, you can easily confuse yourself as log of 2x, which is not what you're saying, okay? You're saying log of 2 times x. So that's why it's a lot better to just put the x out in front first, okay? So since we know log of 2 is just a number, we are going to divide both sides by log of 2. Okay, so what will x be equal to? This is what we're going to do. We're going to do log of 10 divided by log of 2, and then I'll get my results, which is 3.32. Okay. Okay. Now, let's do another example here, okay? So number 4 is definitely one of the trickier ones. So let's talk about this right here. So notice I have 2 to the x plus 1 is equal to 5, 1 to the minus 2x. And then you can take the log of both sides. Now, I have a bunch of things on my exponents, so I'm going to bring the whole thing down. Okay, so it's going to be x plus 1 times a quantity log of 2 is equal to 1 minus 2x times log of 5. Okay, now let's talk about this here as well. If you have more than one item in the exponential form, in the exponents, write this in parentheses, because watch what happens if you don't. Right? If you don't put parentheses, it looks like this. So if you notice, these are not the same thing, okay? So don't write it like that, okay? That's going to confuse you a lot. Now, you have log of 2 being multiplied to both of them. So I'm going to distribute. So I have x log 2. Remember, always put the x in front of your logs, plus log of 2. And then I'll distribute right here. I have log of 5 minus 2x log of 5. Okay. So let's talk about how I solve for this. So remember, when you solve for x in an equation, right, generally for the most part, all the x's go to one side and then everything else goes to the other side. So here, I'm going to move this one over. And then here I'm going to subtract, right? So it's going to look like the following. It's going to look like x log of 2 plus 2x log 5 equals 2 log of 5 minus log of 2. Okay? And then what I can do is, remember, since they both share an x, I'm going to pull this out. Sorry, I forgot a 2 right here. So I have log of 5 minus log of 2. And then you're going to divide this whole thing by the stuff in front. So it's going to look like this, right? Log of 2 okay. You have x is equal to log of 5 minus log of 2 divided by log of 2 plus 2 log of 5. Okay? This is your exact solution. If they want approximate, you'll throw this in your calculator. Be really careful though when you do this. Put the top in parentheses. So you do parentheses log of 5 minus log of 2 divided by parentheses log of 2 plus 2 log of 5. And you'll get the following here. You have 0.234, okay? So your approximate is 0.234. Okay, if you're not comfortable with that, that's okay. What you can also do is you can just put the top in your calculator first and then the bottom in your calculator second, and then so do them separately and then divide from each other. Okay, I can also show you this. Is it second window? No, that's not it. So this is what you would actually do. You'll do the following. You'll go math, and you go to NUM, and then press the up arrow. And the one that says n over d, that means they just want you to write it as a fraction. And then you can have it this, and then you can type it in. So I'm like log of 5 minus log of 2. And all over log of 2 plus 2 log of 5. Okay, and hit enter, and you get the same thing. Okay? So do take a look at this one here. Practice types like these. Yeah, so the ones that have more than one term, the ones that have like 2 terms each for each exponent, those are the ones you have to be really careful about because they tend to be a little bit tricky. So remember, you want to move them so they're in parentheses and then distribute for the following. Okay? Okay. So yeah, take a look at this. Try this by yourself. If you have questions, let me know. Okay? We can definitely look at more examples like this later. Okay? So let's talk about this next one here. Okay? So let's say you have stuff and they say solve by graphing. So these logarithmic equations you cannot actually do, okay, by hand. So you actually have to use your graphing calculator. So let's talk about what to do with them here. Okay? So what I'm going to do is, let's say for example we look at number 2. I am going to graph each one separately. So the left hand side of my second equation I'm going to type in. So I'm going to say this is e to the x plus natural log of x. Okay? And then right here, I'll just type in 4 and I'll graph both of them. Okay? And I always want to see where they intersect. So if you notice, right, my 2 graphs cross at this particular point. That point is actually my answer. So how do I do this? I'm going to do second trace, and then I'm going to go to option 5. Okay? I'm going to move my cursor around. I have this little cursor guy. I'm going to move him till he's close to where my 2 lines intersect. And then all I'm going to do is I'm going to hit enter 3 times. 1, 2, 3. And it gives it to me right here. So my x value is 1.315. So now I'd say this one here, x is equal to 1.315. Okay? So let me show this again. Right, so you graph the left-hand side and the right-hand side, you split them up, hit graph. Then you hit second trace, go to number 5, scroll over and hit enter 3 times. 1, 2, 3. That would be your answer right there. Okay? So that's what you would do if they say solve by graphing for the following. Okay. Let's talk about the very last type of problem. So let's just talk about what we have. So remember in 4.4 you can solve by using change of basis. You can do solving by combining logs, right, using your logarithmic properties. You can use logs to move exponents down. And the last one we have is quadratic in form. So these can be a little bit tricky, okay? I'm going to show you 2 examples right here. So let's take a look at this first one right here. Actually, let me Sorry, let me just move that up. Okay, so this is kind of confusing, right? We have this random exponential form. So what I'm going to do is I'm going to manipulate this and do something called U substitution, okay? If you're in my Math 945 class, this is something you need to make sure you practice for the following, okay? So you're going to do this, okay? I'm going to make U be equal to 3 to the x, okay? So my middle term, I'm going to make that U. I'll talk about how you know you're correct, okay? And then what I'm going to do is I'll square both sides. So if I square both sides, right, that'll be U square, and then 3 to the x, if I square it, right, power to power, it'll be 3 to 2x. So I have U is equal to 3 to the x, and U squared equals 3 to 2x, okay? So notice this becomes the following now. This becomes U squared plus U minus 2 equals 0. I'm doing substitution. So the reason why we do this is because now it's in quadratic, and then I can just factor this. Okay? So this is going to be U plus 2 times the quantity U minus 1. I'll set both of these equal to 0. So I have U is equal to 1. And then I solve this one equal to 0, and I have U is equal to negative 2. Okay. Now, let's talk about this right here. We are actually not done because I need to solve for x. So this is what I'm going to do. So I have U is equal to negative 2. I replace my U with 3 to x. I have 3 to x equals negative 2. Here I have U is equal to 1. So I have 3 to x is equal to 1. So remember, how do I solve for x? Take the natural log or log of both sides. It actually doesn't matter which one you use. If I take a log of both sides. Okay. Now, remember, you cannot take a log of a negative number. Okay. If you forgot, just throw it in. You're like, what's log of negative 2? It's not real. Okay. So this one here doesn't work. So I'm going to take the log of 3 to x and log of 1. Remember that x goes down. And then remember what I'm going to do is I'm going to divide both sides by log of 3. So if I put this in my calculator, log of 1 divided by log of 3, and I get the following. I get 0 as my answer. And that's my final answer. Yeah, so they'll ask you to, generally they'll ask you to write this, a problem like this in approximate form. Okay. Okay. Okay, so let's look at something like this right here, okay? So, one thing is when you're doing kind of the substitution method, you want to make sure they have the same base. So if you notice, I have 49 to the x and I have 7 to the x. I want them to be the same. So the first thing I need to realize is this is just 7 squared to the x. So this is going to be 2, and then it's 7 to the 2x plus 11 times 7 to the x plus 5 equals 0. Okay? So this one's a little bit tricky. Okay? So let's talk about this U substitution. I know some of you guys are a little bit thrown off. Okay? So let's talk about this, right? How do you know if you have to write U? So make sure everything's in standard form, and then you want to make sure that you have you want to make sure you have the right U. So what you can do is let's check. So let's say, for example, I think u is 11, okay? Notice if I square both sides, I have u squared as 121, okay? I can clearly see, here's the thing, I can clearly see that 11 isn't going to work because I don't even have a 121 here, okay? So that's why this one's not correct, okay? Let's say if I thought u was 11 times 7 to the x, right? Notice if I square that, I'm going to get 121 and then 7 to the x squared. I also don't see a 121, so that one's wrong, okay? Or for example, let's say I think u is equal to 7 to the 2x, right? Notice if I square both sides, right, I'm going to multiply. So I have 7 to the 4x. As you can see here, I don't have 7 to the 4x, okay? So when you do your u, and then when you square, both of those items should match some piece of your equation, okay? So these are all wrong. Let me erase this. So my u is going to be 7 to the x. Let's talk about why. Because if I square both sides, so x to the second, right? If you have power to power, you'll multiply. So if u squared equals 7 to the 2x, which we do, right? I have 7 to the 2x, and I have 7 to the x. This is what it's going to look like. It looks like 2u squared plus 11u plus 5. I'm going to factor this. This becomes 2u times u plus 5. So it's going to be 2u plus 1, u plus 5. Remember this as well. If you're not sure you did it correctly, right? If you factor it correctly, multiply it out, and it should be if you multiply it out, it should be what you had originally. So I'm going to solve for u for each one. So this is u is equal to negative 5. This is u is equal to negative 1/2. Okay? So we're going to plug these back in. Do not forget about this part. Because remember, you're not solving for u, you're actually solving for x. So we said u is 7 to the x. So I have 7 to the x is equal to negative 1/2. And 7 to the x is equal to negative 5. Okay? I should clearly realize they both don't work. But if you're not sure, look at what happens if you take the log of both sides. Okay? If you put log negative 1/2 in your calculator, it's not going to work. Okay? But like, let's say if you divide, right, you'll have the following: x is equal to log of negative 1/2 divided by 7, right? Log of 7, right? And so if I divide this, I can clearly see it doesn't work, okay? So, and the reason why is you cannot have log of a negative number. It just does, remember, it does not exist outside of your domain, okay? So same thing here too. Here I notice have log of 7 of x and log of negative 5. This one also doesn't work. So I actually end up having no solution. Again, that is possible here. Okay. Feel free to practice some more using the worksheet that we have here. Again, if you have questions, let me know. As you can see, 4.4 is a tricky chapter or tricky section. So please practice a lot more. If you have questions, let me know. Or send me an email or post in the discussion forum. Other than that, I'll see you guys later.